Hi, all right, so we are going to start looking at the periodic table. Um, First off, you're going to look at your notes, which are a little bit different. You're going to be on the back side. We're going to start by looking at who came up and how the periodic table came to be. So first it was proposed independently by Julius Mayer and Dmitry Mendeleev. So Mendelev's the one we're going to really look at from 1834 to 1907. He published in 1872 and was an attempt to organize or categorize inorganic chemistry. So in order, what he did is he ordered them by atomic mass and grouped them by chemical properties, which you'll see there's going to be a little bit of issues with certain ones. So he predicted the existence of properties of still unknown elements, and he successfully predicted some properties of something called an exasilicon, which in 1871 was found to be germanium, and that was discovered in 1886. So what, 15 years later, they discovered that, which is kind of cool. The problem, though, with his idea, his arrangements, is some of the elements were out of order by mass. What I mean by that is like looking at potassium. Potassium is lighter than argon, but the characteristics don't match up if you were to switch them in the periodic table, which we will get to. So the modern periodic table, that's the one you see behind me right there. That one was by Moseley. Henry Moseley from 1887 to 1915, and he was only 28. Proposed the concept of the atomic number. 2 years after Rutherford suggested the existence of the nucleus, so he assigned a whole number to each element and correctly identified it as the number of protons in the nucleus. So the atomic number, that's the one we use now. As the atomic number, which goes by the amount of protons in the nucleus. So he also identified holes in the periodic table that led to discovery of even more new elements at that time. All right, so we're looking at the lovely periodic table. This is an older version, so please bear with me. So you're going to look across where you're having periods. There's 1, 2, 3, 4, 5, 6, 7 of them right there on the side. We're not going to look at these. These don't get included at this moment in the periods. And then you have groups. So periods are side to side, groups are up and down. So we have 18 of them, and this would be considered 1, 2, 3, 4, 5, all the way over to 18. Okay? And so again, in your notes, periods, they're horizontal. They go across like this, like we're looking at the horizon. There's 7 of them. And this is when we went over the energy levels. This tells you their energy levels. Same number of occupied energy levels. So period 1 only has 1. Period 2 has 2. You have the 1s, 2s, and 2p. And then 3, 4, 5, and so on. Groups, however, those are the up and down. There's 18 of them. And in these, especially in the non-metal metal on the sides, not the transition metals, but on the sides, these elements tend to have the same valence configuration, meaning the valence shell has the same number of electrons going down the row. So 1 has only 1, 2 has only 2, 13 has only 3, 14 only 4. And they're also similar chemically, which we will get to. All right, so this is showing here's the periods, and here are the groups, 1, 2, 3, 4, and so on, right? And you can see there's only 1, there's 2, there's 3. All right. Okay, so now we're going to look at metals. And here are all the metals. And what I would like you to do is to highlight color around, just do an outline with the line on the metals. And yeah, you can go down for the R, D, and CN right there. So you're going to do all of them. and you're going to just not highlight, but outline it with a green, a light green, and you're going to label it metals. And then you're going to have the nonmetals, which are right here, and outline these again, but in yellow. And now we have the metalloids, which are going to be this section right here. There's 7 of them. And do these in black. Do the boxes in black, and don't forget to make that key so you know what you're looking at later. So metals versus non-metals. So metals have luster. They look like metals. They are shiny like metal. They conduct thermally and electrically. So they conduct heat and they conduct electricity. They're flexible. They're malleable. They're in sheets, or they can be put in sheets. They can be put into wires. Think of like copper. You can have copper sheets, copper wires, aluminum. You can have aluminum sheets, aluminum wires. And these metals, these form cations because they lose electrons. The ions are going to be smaller. That's what this means. They're smaller than the atoms. So a normal atom would be like this. When it loses, it's going to be a little bit smaller. All right? And they are solids except for mercury. Mercury is the special one. And then we have these nonmetals. These are dull. They're not shiny looking like metal. They're poor conductors. You don't want to use them to conduct anything, but they're insulators. They can keep you from burning or getting heat, burning your hands either electrically or heat-wise. They're brittle. They break apart. You can't put them into sheets. And these guys, they gain electrons. So they form anions. They gain. AI, with the AI right there, anion, AI. That's one way to remember them. And these, so the atom, the regular atom is like this, but when you gain, you get bigger. All right, so these ones get bigger. And these ones are mostly gases. The one that's special is bromine. So bromine and mercury are the only 2 on the periodic table that will be liquids. And that is it for right now. If you have any questions, please don't hesitate to ask. And I hope you have a great day.